There we go. Good afternoon, everybody. Welcome to class today. Thank you for joining me, whether you're joining live or you're watching the recording. I just appreciate you watching. Little problem with the microphone to get us started today, but I believe we've got it all worked out here. So we can go ahead and finish up talking about normalization. So we're finishing our discussion of normalization today, and what we're going to do today is I'm basically just going to kind of give you some insight into my process about how I would do normalization. So we're going to kind of look at our preschool example that we did a couple weeks ago. I'm just going to kind of work through it, maybe do some examples in my SQL workbench just to give you a little bit of insight about how I would do this or how you might want to do this for your lab assignments. But again, your mileage may vary. Obviously there are multiple different ways to solve this problem. And I don't necessarily expect you to get everything 100% correct in this particular lab assignment. Right? I do have some some leeway kind of built in to these assignments here. So there is that. Right, but this is, I believe we'll have one more sort of live class after this one, and it'll just be a short one. Right, because we're basically at the end of the semester here, right? Like after today, the next live stream we have will be into December. Right, December 12th being the last day of class. We are, right up here against the end of the semester. Everything is almost complete. We're almost done with our semester. Seeing, how far you all have come this semester, I think you all have a lot to be proud of. You've accomplished a lot of things, as per usual. So there is that. But today we're talking about, we're finishing up database normalization. And I just kind of wanted to kind of go through a process of examining, okay, what do I want to do? How do I want to approach database normalization? What would I do in these situations? In terms of how I would take a database and design a database. And so I'm going to kind of do a truncated process here, and it might take us our whole hour. It might not. I'm not entirely sure yet. I'm kind of winging it to some degree, right? Like I prepared a little bit here, but I really wanted this to be authentic in terms of how I would approach the problem and introducing you all to that. So I didn't overly prepare for this one. So I'm in Notion here. To start out, I'm using the website Notion, notion.so. You could be, using whatever you like. Notion's just it's a souped up note-taking site, souped up task. It does all sorts of stuff. It's pretty cool. You could use a Word document. You could use OneNote. You could use a pencil and paper. you could use, whatever you're comfortable with in sort of doing this same type of thing, right? Like all we're trying to do here is just have a place where we can kind of get some thoughts into an area. Right, because what I'm going to try to do here is going to be more akin to what I'm asking you to do for like your final project. Although, in terms of all of that, like it's actually easier for the lab assignments in this module since you've already been kind of given the columns and or at least most of the columns and most of the things. You've already been given this data for your database. And you're not having to make it all up from scratch. So you're getting that. You have that luxury there. So I'm going to, try to make up a little bit of a database from scratch. I'm not going to do the whole thing. And then I'm going to, do a representation of implementing it into MySQL Workbench from there. And we'll see how that goes from there. So I'm in my Notion workbook here. One of the cool things about Notion is that I can insert all sorts of stuff with it. I can insert some pages, text, to-do lists, headings, tables here would be great for, using for databases, lists, all sorts of things. It's really, really cool. You can actually insert table views for databases. Which, in this instance, it's actually, kind of treating it like a database. So it's not exactly what we'd be looking for here in terms of, database design, right? Because it actually is a database. But I guess you could use it for that purpose. Different media, code, it's designed for programmers. Right, so we can embed files, we can use Google Drive, we can embed tweets, embed things from GitHub, from Google Maps, from Figma. From Replit, all sorts of things into here. It's a really neat piece of software. If you've never, if you've not tried it out before, it's worth trying out. So what I'm going to do right now is I'm just going to start out by creating a bulleted list here. And this bulleted list is just going to be everything I need in my database. Right? So I'm just going to kind of start out by just sort of stream of consciousness, thinking about, okay, these are the things that I need for my database. So I'm going to have, we're thinking about, Happy Vale Preschool, right? We're going back to that preschool example that we were doing a couple weeks ago. I'm going to need the student's name. I'm going to need to know how old they are. And we talked about a couple weeks ago, how age isn't really a great piece of data to keep in a database. What is more valuable to keep is a student's date of birth. Right, and then we can calculate age and various other things like that from there. Let's see, we'd need parent's name. We'd need a parent's phone number. We'd need a parent's address. And we would need the relationship between the student and the parent, right? We'd need to know which student belonged to which parent. And I think for this proof of concept, right, I think this is probably enough. right? Because I think once we kind of get into and, you know, start to pick apart all this data, we'll get into some places that you know we might want to make some changes or deal with some things. Right, because this could be on its own these 1, 2, 3, 4, 5, 6 entities here. This could be 3, potentially even 4 database tables from the way that I'm looking at it. Maybe even 5 if you wanted to get really pedantic with it. So I think for our purposes here, we can just kind of use what we've got here. We don't really need to break it down any further, right? If we go back to our example, right, some of the things that we were talking about was, you know, like payment information and all that kind of stuff. I don't think we'll do that here just for brevity and since this is proof of concept. So now that we have this understanding, like, okay, I've sat down, I have imagined all the things that I need for my database, I'm going to start kind of dividing things out, right? We can start to kind of look at the way things work. And one of the things that I kind of do is, you know, one of the things that we talked about last week is that, you know, these different normal forms, they kind of build on one another. So if we think about things in terms of third normal form, and we think about all the qualifications that it takes to get us into third normal form, if we think about the litany of qualifications, which includes the qualifications for second normal form and the qualifications for first normal form, then we can kind of jump the line and go straight to third normal form and start to kind of separate these things out and look at you know, all of our functional dependencies here. Which gets us into a good place, right? Because we see a functional dependency here, right? This is a functional dependency. Student's name to their date of birth. That's a functional dependency. So that student, that one particular student, has that one particular date of birth. So we can kind of assume that, you know, we can make a table here. Now this will be our student table, right? That we'll be using with student information here. Since students can have the same name, and we don't want to get into any of our data anomalies, we want to have some sort of unique identifier for us for when we are building this table so that we can uniquely identify these students. So we're going to need to establish some sort of primary key that is separate from student's name and student date of birth. Right? We could get by potentially on using both of these items together as the primary key, but even still there is that infinitesimally small chance that you have two students that share a name and a date of birth. Right? That's a really small thing that could happen, but it could happen. Right? So if we're going to look at it from that perspective, in order to kind of build ourselves a table here, let's add a heading here for our first table. We'll call this our students table. And in this table, we will have some sort of student ID. that we can use as that primary key. Right, so we'll put PK here to represent that is our primary key for this table. And that student ID has a functional relationship with that student's name. And so since this is for the table, we'll call this student name and student DOB, or student date of birth. Right, so now that we have those represented in a table somewhere, we can check them off of our big list. Now here, with parent's name, and parent's phone number and parent's address, this is where we could get into the weeds when it comes to our functional dependencies and trying to get things into normal form. Right, because in this case, what we're saying here is that we really don't care about anything else that's personal about the parent other than their name, right? Like in this particular table. In the real world, we might want some other different things here, but in this particular case, like the only real personal thing that we're having here that's related to the identity of the individual is the name. Right? No date of birth, no social security number. You know, in the real world, we might want some of that. In this instance, you know, just as this proof of concept, we are not doing that. So the parent's name isn't necessarily dependent on the parent's phone number. And the parent's name isn't necessarily dependent on the parent's address. These are things that belong to that parent, but they are not necessarily dependent things. And these are things that could be could apply to multiple people. So if we really wanted to kind of get into the weeds with this and try to ensure third normal form, to ensure functional dependency versus I've lost the word, the other type of dependency where, you know, it's a relevant dependency but it's not directly related. I've lost the word. We were talking about it last time. Right, like it's a relevant dependency because the parent lives there, but it's not necessarily dependent on this thing. Right? Like we talked about it last time in terms of the author and the author's books. And the author's date of birth. Right? We said the author has books, or the books have an author. The author can have multiple books. So the author is not necessarily dependent on the book. And then the author's date of birth and the book title aren't dependent on one another at all. So we could technically make each of these three items their own table if we wanted to. With a particular... Now here with our parent's name, we do need some sort of unique identifier there. We would want a parent ID to go along with that. so that we could have a unique identifier here. So if we wanted to do that, we would want a parent ID that would work as our PK, and then our parent name. And that would be technically all that we would need for this table. We could have another table for phone numbers. And I know this is occurring because I keep hitting enter instead of just clicking, which I should just come up here and click. And just have one for phone numbers. Need to get more used to because there is a way to make this a turn into heading one. There we go. Get more used to Notion. Start using it more. So in this case, I would want to use parent ID here. In this case, parent ID is not my primary key because parent ID does not directly relate to phone, but parent ID is identifying the parent that is connected to the phone number. So it is creating my relationship between the parents table and the phone table. So it's acting as my foreign key in this instance. Now we can put the phone number here. And that is technically all I need for that. Since we're not using primary keys here, we can have one instance where, one user could have multiple phones, a primary and a secondary, or even a tertiary, right? You can have one call and return multiple phones here and work with it that way. The same thing here for the address, if we wanted to do that. Parent ID as the foreign key, and address. And then finally, we need the relationship table. This is going to be a completely separate table. In this case, we're going to be taking the student ID and just relating them with a parent ID. So student ID, which in this case would be working as a foreign key, and parent ID, which would also be working as a foreign key. So since we're not identifying unique information, since this is just to divide up information so as to try to prevent data anomalies, right? And if you'll remember back, one of the things that we said last week is that if we, one of the easiest ways basically to ensure that we only have direct dependencies is basically having tables with 2 items in it. So it really makes this database here in particular a very, we might have overdone it, right? There are multiple different ways to do this. And if we had more information about our parents here, we might, put more information in here, right? For example, if we were putting their SSN, their social security number in here, if we were putting the parent date of birth in here, we might do that, right? Because those both have direct relationships to the parent. Right, for that matter, we might want to put student SSN in here, right? However we want to sort of expand our database out. But one of the things to kind of note here is that social security number, probably not going to change. Date of birth, probably not going to change. Phone numbers can change. I know from having, from trying to call you all on occasion, people change their phone numbers a lot. Addresses, people move. Right? So by taking these and putting them in their own table, it's going to minimize the possibility for insertion and deletion anomalies based on this information. Right? We're not going to accidentally delete vital parent information if we have to drop a secondary phone number. Right, so we can end up with a fairly good, fairly normalized database that looks something like this, right? Nothing's, everything is, this is fairly well in third normal form. And so if we were to, and just for the sake of completion, we can go ahead and put our green check marks here. And so now we have a plan, right? And we can take this plan and we can move it into a database. And your lab assignment has you working with, and I'm just going to move this over to another window so I can still see this while I'm working in my SQL workbench here. So you can do this manually, right? If I wanted to go into an existing database, I can start to do this manually, where I can create database, and create all my tables and do everything that we need to do there. But one of the things that I could do in my SQL workbench is I can create a new model. And your lab assignment asks you to use MWBs, which is a MySQL Workbench model. In this case, there's an ERR design file. I have this video here that talks about EER diagrams, and I also work with some EER diagrams here. You don't really have to get deep into EER diagrams to be able to work with this, right? I'll go ahead and download this, though, just to show you how to open that in a minute. Once we get there. But I can create a new model, right? So I can go over to File, New Model, and it's going to create a new tab here. And this is going to give me a schema, and I can actually start to use this GUI to create things. So this MyDB here, I can change that to Happyvale Preschool, for example, right? By just double-clicking the name, it opens it up in a new tab down here at the bottom, and that changes that to, gives me the option to be able to rename it. I can also add a table by just double-clicking it. I can give the table a name, for example, students. Tells me my schema is Happyvale Preschool. Name the table students, and then I can start to give the columns names. Right, so I give it a column name, student ID, set a data type, which is going to be integer, but I could also pick from the drop down whatever I want it to be. But I do want it to be an integer. PK is primary key, NN is not null. And that's all I need. So I can keep going. I can click down on the next line, it'll populate another line for me. And I can click into that and add my next line. Student name, varchar 45's just fine. I can click into not null to make that not null. Click into the next one. Student DOB. If I want to, I can make that a date property and a not null. And finally, we're going to do student SSN. And yeah, we'll give that a varchar, but that'll be we'll make that varchar a little more specific than 45 because SSNs are 3, 2, and 4 with 2 dashes in them. So that's 9, 10, 11. So we can make that a varchar 45 into a varchar 11. And that one that it added there by accident, we can just delete that. And then we have a students table here that we've created. We'll make it not null as well. You can see here where we can add a diagram. That's that EER diagram that we were talking about there. Question here. For the lab assignment, are we going to be submitting a Word document with everything that we click on, or once we create it? See, I'm asking for the MWB, right? So I'm asking for the MWB. In this case, there's a couple queries it asks you to run. It asks you to run show tables. It asks you to run describe, and it asks you to export the database. So there's a couple files for that. But I am asking for the MWB, and I am going to show you how to save the MWB, which it really is just as simple as file save model as, and it'll let me save an MWB. But yeah. Yeah, so in this case, I want the MWB of the normalized database. So you'd open this one up, you'd normalize that, which we'll have a look at that in just a minute. And then you'll just save it and send me back the .mwb. And then in this one, you'll open it, you'll normalize it, you'll add some data to it, and you'll run a few commands, and you'll send me the MWB and the results of the commands. But I can add a parents table here. Does that make sense? Yeah, and I'll open up the employees one in just a minute and show you that one. Just do some simple things with it. So once you have it, you can save it, file, save model as, testing, or we'll just call it preschool.mwb. And then I could load my model preschool.mwb. And we get it right back. And from here I can import or we'll mess with all that later. And so now I can just play with this here and I can see it and go through and look at it. So let's open up that employees one and have a look at it. So file, open model, employee. So this is the EER diagram. And so I can also look at this, just the regular physical schemas here. Right, I can click on it here and I can see it. So in the EER diagram here, I can kind of double click and I can get these things where I can edit them. And so just like I was doing there, I can, like for example here, employee. Employee ID, employee name, employee email. Might be good for an employee table. These dependents might not be good for this table, and we might need to have multiple, instead of having dependent 1, dependent 2, dependent 3, since you could have any number of kids, we might just want to have a table to where we can have an employee with their employee ID and the name of their dependent. So what I can do here is I can just create a new table. So let's see if I can remember how to do this from the EER diagram. It's been a minute. We have place a new table here. And then I just basically draw that on. We'd call that table dependents. We would add, say, employee ID to it. We'd want it to be the same as this one, since this one is, it'd be the same value, so we'd want it to be a varchar 45. Now in this case, this is not a primary key for this particular table because it's not a unique identifier for every dependent in this table. So we'd want to remove the primary key here. It would be a foreign key in this instance. So it would connect this table to this table. And we could put dependent name in here. Varchar 45. If you had some other dependent information in there, which we're not asking for any other dependent information in here. But in this case now we could remove this dependent information by just deleting it from the first column. And that's one step that we could do to help normalize this database. Right, we're just, that's basically, that's one thing that we can do, right? Because we took those things out of there, put them into their own database, use the employee ID to reference that, so now we can relate that to that, and that's that. Yeah, you don't want to overthink this. You're not really doing a whole lot with code here, right? And once you're done, you just file, just save that model, upload it back up, and you're good. Does that have you feeling better about it, Matthew? Sure doesn't seem too confident. Like at the very least you can do this, right? Like it's just double clicking and editing. I double click, I edit, I draw on a new table if I need a new table. If I want to get rid of a table, I delete it. Right. This is all GUI. True. Yeah, you don't want to overcomplicate this. And really, for this, I was telling somebody else, I don't necessarily expect it to be perfect. Right? I just want to see you all, made a good effort at it, right? Because it's not, especially when we're just kind of learning about it for the first time. It's probably not going to be perfect. So if we just give it a good shot, put some good effort into it, then everything will be fine. One of the big things here that we can kind of see is, we look at these tables and we see okay, what are some things in these tables that could change versus what are some things in the tables that probably won't change. If they could change relatively often, right? And you'll also want to make sure that you reference back to here because it tells you name and role and employee contact name all refer to the same data. Name and email and vendor refer to the vendor. Right, so that's one thing that you might want to look at is maybe normalizing, and that's normalization in maybe a different sense there. Just normalizing what you're calling those columns, just so it makes more sense to you as the database administrator. Right, we could also look at this one really quickly, the people one. So I saved that one. Save. File. Open model. People. So we can see the people here. The first thing that you'd want to do is you'd want to normalize it. Once you have it normalized, you'd want to forward engineer this into a database, because that's going to create all your queries for you. Now I can go here, I put it into here, so I can use, and this isn't normalized yet, but I could right, we could use, is this one just called MyDB? Yep. And describe tables. Or no, I'd want to describe, I'd want to show tables. Yeah, and people and registration. People and registration. Right, so that forward engineer there, when you're done getting it all normalized, will actually turn it into queries for you. So you just click that forward, you'd go to database, forward engineer, you'd select your stored connection that you already use. Mine's DBA 110. You just go next right over that, and it'll tell you, like, okay, this is what I'm going to do. And these are actually all the queries you'd need to write. So it actually writes all the queries for you. And so then in your database here, you could work with people.txt that we have here and add that information into your database as you need to, using all the queries and things that we've learned. So you'd normalize first, forward engineer, take this data, add it to your database using the stuff we learned in the previous module. Then run show tables. Run a describe for each of the tables that you created. And then you'd also save the model. So from here you would save the model so that you can send that model back to me. Easy, 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 easy. No big deal at all. Right? No big deal at all. And since you're already starting with the data in terms of, you know, kind of what we have, like this, you just have to determine, okay, how, you know, how would this data work best? How could I best normalize this data? And obviously, you know, big hint here, you know, having the 3 countries and the 3 registereds isn't going to work. So with that, I believe that that's all that I have for you for today. We'll take any questions if anybody has them. Otherwise, we'll go ahead and we'll start wrapping up. Try not to overthink it. It's not as hard as it looks. And again, remember that the big thing is that I just want to see some effort here. I don't necessarily expect it to be perfect, right? Because especially while we're learning, it would be incredibly difficult to get it perfect the very first try. So some good effort would be where my expectations would lie here. So with that being said, thank you for watching. We will have one more, just kind of a more of a check-in sort of live stream as you are kind of working on your final projects. If not probably next week. With that being said, that's all that I have for you for today. We'll turn on the music for just a minute, and anybody who might have any questions who's watching live, we can answer those. If you're watching the recording and you have any questions, feel free to send me a Teams message or an email. Thank you for watching. We'll see you next time.